Okay, good morning class. So today we're looking at problem solving, 2D and 3D, 2 dimensions and 3 dimensions. At this point we have concluded number 1 to 3, so now we're looking at number 4. Okay. People, here we are told that in triangle Q, okay, first change this now to a 4. So here we are told that QPS, we are told this angle theta, that is 60 degrees, that is A. In triangle Q is on, this is theta, that is 90, and that is K. Prove that K is equal to that story. Where do we start? Where do we start? Not by skipping the sum, no. We will start by the subject of the formula. Not so. So in this formula, in this triangle here, you should see 90 K is Q theta R. Okay? So we're going to have to use the K and we have to use the QS. Why must you use QS? It's a link between the two triangles. No? So which trigonometric function uses opposite and adjacent? Tan again. Okay, why can I use tan here? The right angle triangle. Not so. So we say in triangle Q is R. You're going to say that tan of theta equals opposite over adjacent. I make K the subject of the formula. So K is equal to QS tan theta. You will agree with that? Now let's look at the other triangle. So in this triangle here, what do I have? I have Q S, which is 60, theta, A, P. So what must I use? I must use QS. So then I need to know what that angle is there. Not so. I'm going to calculate that angle. Sum in triangles. Not so. We must pick up A. As you can see, A is in the formula there. Okay, and we have this angle here. So which rule? Sine or cos rule? Sine rule. So in triangle PQS, the sine rule, I'm going to make QS the subject. So QS over angle P. But we need to calculate the angle P first. So angle P is going to be 180 minus 60 plus theta. You all agree with that? So now we say that QS, note that I'm not multiplying the story out, okay? QS over sine 180 minus 60 plus theta equals A over sine of theta. The reason why I kept it like this is because I can apply reduction formula easily. Okay, 180 minus 6 in the second quadrant is sine positive, negative in the second quadrant. Positive. So this is simply QS over sine 60 plus theta equals A over sine theta. Take that up, where I cross multiply, it's going to be QS sine theta is equal to A into sine 60 plus theta, and then I divide both sides by sine theta. But QS is also equal to A into sine 60 plus theta. I don't need that bracket there. Over sine theta. Okay. But what does this sine 60 plus theta remind us of? What does this remind us of? Special angles. Yes, what else? 60 plus theta. Compound angles, people. Not so? Compound angles. This can be written as what? So Q is going to be A into sine alpha plus beta can be written as sine 60 is cos theta plus cos 60 sine theta. And this is all over sine theta. But now sine 60 cos 60 remind us what? Of the special angle, not some. So if that is 30 is 1, 2, root 3. And of course 60 lies there. So we have A into, what is sine of 60? Root 3 over 2 cos theta plus sine cos 60 is adjacent of hypotenuse is 1 over 2 sine theta all over sine theta. Okay. You all agree with that? So let's see what they have here. They have it apart, okay? Can you see that? So what I'm going to do is, I'm now going to replace QS with the story here. Not so. That's what QS is equal to. So therefore, K is equal to A. I'm going to multiply this out now. A, so it's root 3 over 2A cos theta plus of A sine theta, and this is all over what? Sine theta, not so. But what I'm going to do is I'm going to put each one over its own, so otherwise I must rewrite the same story again. Put each one over its own. Sine theta, sine theta. This is all what QS is. Not so. What must happen? I must still multiply that by tan theta. This is tan theta. Okay. So what's going to happen here? What is cos over sine? Huh? 1 over 10. Because I sine over cos is 10. So cos over sine is 1 over 10. So this can be written as the square root of 3 over 2 A over 10. Tan of theta. You all agree with that? Because this was now 1 over 10. Okay? Plus, what's going to happen here? Signs cancel. Which leaves you with half A times tan of theta. But this is now tan over 1. And that is 1 over 10. Can you see that, people? So what do you think is going to happen here? When you multiply it in, it's going to cancel. That goes in there. So what am I left with? So 1 over 10 would cancel that out if I multiply that in. So it's going to be root 3 over 2A plus half A times tan theta, so half A tan theta. And that is what they asked you to prove in there, is that K is equal to root 3 over 2A, which is there, plus half tan theta, which is there. Okay? Easy. Okay, we're not finding it easy yet. The only way it's going to become easy if you're going to do a few of it on your own. Okay. People, one of these proofs are, or what you needed to prove is not correct. No, I think it's this question. Let's check, is this it? No, it was the previous one. You see there's no A here. No? But there's an A here. So it's fill in A in the book. You check your textbooks. But there's the A. Does your textbook have the A? Okay, I have the older version of the textbook, okay? Before you think I made a mistake there. People, we are told die number 5. I'm moving too fast now. Okay, I'll try to move a bit faster. Number 5. Okay. People, we are told that CD is a vertical tower. From A, the angle of elevation, which means to say the angle that goes up. From A, the angle of elevation of D is alpha. From B, the angle of elevation to D is beta. The distance between B and C, which is the foot of the tower, is 5 meters. And the distance between A and B is x. Alright. Find BD. So BD in terms of alpha and beta. Now, if you're looking at this triangle here, will I be able to pick up alpha in that triangle? No. Remember, this whole angle is 91. So it's not going to help us. Okay. So which means to say I'm in fact not working with that triangle. Can you see that? So it's definitely working triangle ABD. So in triangle ABD, you see this is beta. Not so. So what relationship exists between beta and alpha? We know that angle beta is equal to alpha plus ADB. Not so. Why? Exterior angle of triangle. So I can say that ADB is equal to beta minus alpha. Exterior angle of triangle. Did I need a reason here? No, you don't need it. Okay. But if I write it in am I going to get the extra mark? Of course not. No? Otherwise I would tell you, write it in. Okay. So now we have a triangle looking like this. We got alpha, we got an x, we got ABD, and we got beta minus alpha. So what must I use? What must I use? I must use BD. So that's what they ask you. You're not going to use this angle here. You've got another angle, so I'm going to use that opposite and that thing. So which rule is that? Many angles. You're going to use that? Yes. Please have a good night's sleep for tomorrow's lesson. Okay. So what do we say? We say that BD over sine alpha equals x over sine beta minus alpha. So what are you going to make the subject of the formula? BD. So we take it up. So BD is equal to x sine alpha over sine beta minus alpha. People, can I cancel the sine alpha here with this alpha? No. Alright, so there we got BD in terms of alpha and beta. Can you see that? So we put that in our diagram. So BD is going to be x sine alpha over sine beta minus alpha. Okay, so take this off here. So I'm going to try and keep the diagram in focus. Right, let's look at the next question. Now show that x is 5 into tan beta over tan alpha minus 1. X, where's the x? There's the x. You see there's a 5 here. You see that? And there's the 5. So what do you think we're going to do here? We're going to working triangle. A B, D, C. What do we have? 90. We have 5 meters there. We know this is that story there, not so? And we have a beta here. So what can be done here? Because that's a right angle triangle, I can use sine, cosine, tan. So which trigonometric function am I going to use here? Adjacent. And hypotenuse, which is what? Cos. So you say in triangle BCD. We're going to say that cos of beta equals adjacent, which is 5, over hypotenuse, which is BD. So what I'm going to do, you see there's no BD here. Can you see that? So what I'm going to do is I'm going to make BD the subject of the formula. Cross multiply, so BD cos of beta is equal to 5. Divide by cos beta both sides. So BD is going to be 5 over cos beta. But they ever answer the question? Remember, this is what BD is. Not so. So if BD is equal to 5 cos beta and BD is x sine alpha over sine beta minus alpha, then what can you conclude? You can conclude that therefore 5 over cos beta is equal to x sine alpha over sine beta minus alpha. But still I didn't answer the question. Not so. So I'm going to make x the subject of the formula. And take that up and the sign down. So it's going to become 5 sine beta minus alpha. So that's it. Then we have over sine alpha cos beta is equal to x. Ever answered the question? Still not. But we now note that, hang on, that is the issue there. Well, that I can change at least. Not so. So sine beta minus alpha can be written as what? Sine beta cos alpha minus sine beta first alpha cos beta over sine alpha cos beta. What's my mistake here? What should I have done here? Okay, I can't give you an hour or a minute. I need a bracket here. Why? Because a 5 must be multiplied in, not so. So what we do now? We get rid of this bracket here. Also, we put each one over its own. So it's going to become 5 sine beta cos alpha over sine alpha cos beta minus 5 sine alpha cos beta over sine alpha cos beta. So now, what is sine over cos? Tan. So that is 5 tan theta. And what is cos over sine? 1 over 10. Minus, that cancels, Negative 5. So negative 5 is a common factor. So that means you say I didn't need to multiply that 5 out. You're simply going to give me tan beta over tan alpha minus 1. And that's what they wanted us to prove. We have proven it. Alright. Tomorrow's lesson we're going to conclude number 6 and 7. Alright. People enjoy the rest of your day. Good morning, class. Good morning, class. So today we're looking at exercise 1, dealing with 2D and 3D problems. At this point I must still do number 6. Alright. Alright, so in triangle ABC, we are told that AB is equal to AC, which is equal to D, as indicated there, and then we are told that ABC is equal to ACB, which is equal to theta. Then we are told that in triangle BCD, we are told that is theta, this angle here is beta, and there's an X here, and there's a K. Use the cosine rule or the cos rule to show that X is equal to twice D and theta. What do you notice? There's no K and no beta. So what does that mean? It means you say I'm working in triangle ABC. So you should see a triangle looking like this one. You should see a triangle looking like this. But theta, theta, DD, ABC, and XC. Not so. So we have two lengths and included angle, so we need this angle. Not so. So are you going to calculate angle A? Sum of triangles. So angle A is equal to 180 minus 2 theta. Don't need this. So right here, sum of triangles is triangle ABC. Okay. So the cos rule is going to be x squared is equal to d squared plus d squared minus 2 d times d, which is also d squared, cos of 180 minus twice theta. What is d squared plus d squared? 2d squared minus 2d squared. 180 minus, which quadrant is this here? Second. Positive or negative? Negative. Making this negative a cos 2 theta. But is that what we have there? No. So what do you notice is a cos and not 2 cos. A cos 2 theta. So we know that cos 2 theta can be written as 1 of 3. 2 cos squared theta minus 1. 1 minus 2 sine squared theta. And cos squared theta minus sine squared theta. So which one of the 3 are you going to use? The one dealing with? Okay? Because of what we have there. So let's go, we're going to get 2d squared plus 2d squared into 2 cos squared theta minus 1. We did that bracket there, so it's going to be 2d squared plus 4d squared cos squared theta minus 2d squared. That cancels, leaves you with 4d squared cos squared theta. Square root. You use plus minus, but we're talking about length, so it's never negative. So x is equal to 2d cos theta. Okay. Any confusion there? Okay. Let's look at question 6.2. Question 6.2 says now show that. So just keep you in mind that we have proven this here, okay? What if it is right in here? Which is equal to 2d cos theta. Okay. Now the question says, now show that k is equal to d sine 2 theta over sine theta plus beta. So of course we're going to have to work in the other triangle, not so. However, in this triangle here, what do we have? We have x. So we have many angles here, so definitely the sine. But what do I need? I need angle D. And then we have theta, and we have that k there. You're not going to use beta because there's no marking here. And why must I use that? Because that's a link between the two triangles. You guys see that? So where do we start? We start with the subject, which is k. So I say k over sine theta is equal to, now I need d, now I'm going to calculate the sum in triangles. So angle D is equal to 180 minus theta plus beta. Why do I keep that in brackets? So it's easy to do reduction. This is sum of triangles, and that is triangle BDC. Okay. So what do I say? K over sine theta. K over sine theta is equal to 180 minus beta plus theta. So it's going to be x over sine 180 minus beta plus theta, or theta plus beta. What is 180 minus? Which quadrant is that in? Second quadrant. Sign positive or negative? Positive. So that is this, I'm going to make k the subject of the formula. So k is equal to x sine theta over sine beta plus theta. But what is x, people? X is 2 cos. So that can be written as 2d cos theta times sine theta. Okay, so this here is what x is, not so. Before you get confused there, that is what x is. Okay, and that is from the previous question. And this is all over sine beta plus theta. But is that what they asked us? No. What do they have? They have sine 2 theta. But 2 sine theta is also equal to what? 2 sine theta cos theta, not so. But what do we have here? We have the sine theta, we got the cos theta, and we have that 2. You see that, people? So together 2 sine theta cos theta makes sine 2 theta. Okay? So that is equal to d sine 2 theta over sine beta plus theta. Okay. You're not going to master this by seeing or looking how somebody else do it. No? You must sit and practice it. Okay. Not difficult, you just need practicing. People, that basically brings us to the end of exercise 1 on page 120. Okay. The full lesson can be found in the description box below, or alternative lesson.